Hello again and welcome to Mill Lab number 4. So we're going to continue on working on this part right here. Last week or not last week, excuse me, last program and last video, I will name this Mill Lab 4A. We milled the outside, leaving stock in 3 passes, and then we milled out this island, leaving stock, and finished those up. So that's all done up here. You'll need to watch that other video. I'm not going to go over that in great detail. What I am going to do is go ahead and start here. So what we're going to do is we're going to drill these holes. Now it says it wants a tap. We're not going to tap them. We're just going to go ahead and drill them at this time. All right. Tapping's a little more involved, and I want to get some other things going on here. So we're just going to drill these 4 holes. All right. We're going to use can cycles to do that. Now what is a can cycle? A can cycle is like canned spaghetti. Okay. Canned spaghetti is not very good spaghetti. But if you're starving to death, it is a whole lot better than nothing. Can cycles will allow you to do repetitive type functions like drilling holes, and it makes them easier, and you can use less code. So you don't have to put as much, you don't have to type as much, you don't have to worry about making as many mistakes. The problem is that can cycles also don't give you a whole lot of creativity or things like that. So there's certain things that can cycles just won't work well in. So that's the idea behind the canned spaghetti. It's better than nothing, but you know. So we're going to use canned cycles. You're always going to use them. So I've got that down there. Got me some extra spaces. You need to do that too. All right. We're going to do our first tool change. Now up here we've always done our tool change in our startup block. I want you to do this. Go right here and you copy from, I'm copying from line 10 to line 50. Okay. I'm going to go ahead and copy that. And at this point, I'm going to make this thing there. All right. Now, this is how we're going to do a tool change. I'm going to open up a line here, one more, and I'm going to paste. Now let's take a look what we got. I'm going to resequence these later on. I'm going to do that in Predator Editor so you can see how we do that. I've done it a couple times. But there's a couple things we want to do on each tool change. Okay. Now, we got our G28, MO4, MO9. Now, what do we need before that? Well, we're always going to, in every tool change, you're going to have this safety line. So this is exactly what's going on. Okay, this is going to be a standard tool change. Yeah, that's why you just copy the first thing. We're still going to have our G54. This time, we're changing to tool 2 because we are using tool 2, which in this case is going to be a number 4 center drill. So, excuse me. Okay, number 4 center drill. I might change that a little bit here. Yeah, that's fine. Number 4 CD. I'll go back and make it capitals. Hit that caps lock button now. Might as well get that going. The bane of the CNC. There we go. So I got a number 4 CD. There we go. Number 4 center drill. All right. So this stays the same. That stays the same. I changed it to tool 02 because tool number 2 is going to be my number 4 center drill. And of course I got my MO6. Now, how fast do we run center drills? You can do an RPM calculation for the tip. Different size center drills, they come from like 0 all the way up to 6, 0 being an incredibly small center drill, and a number 6 being a very large center drill. If you don't know what a center drill is, it is merely a drill that starts a hole for a drill to follow. Basically, we use them because it makes very accurate positioning. Now, some spot drills will do the same thing. We'll talk about spot drills later on. There is some controversy about spot drills versus center drills as far as accuracy of location goes. We're not going to get into that right here. You can have that debate someplace else. Please don't have it here. How fast are we going to run it? Let me tell you what. In this class, seriously, run your center drills 1250 RPM. All right? That generally works for almost everything. All right? Now, we got that all on. I'm hitting Control S. All right? And let's scroll on down here a little more. Okay, that G43, we do have to change something here. Remember, the T number always has to match the H number, or vice versa, the H number always has to match the T number. So that's HO2. So go back, put a 2 there, very good. Okay, H02, Control S. That'll activate our tool length offset. Now there's still some other things going on here, because you say G28, but what'll happen here? We did turn off the coolant. So I'm going to put another, open up another line here. And here's what we need to do. At some point, okay, whenever we have a G28 and we have a tool change, a lot of controls automatically turn it off. Right now what we're going to do is I'm just going to put a placeholder here. Let's say it's N05. I'm going to put this right here, M01. Now, what is that? That is an optional stop. All right? And what an optional stop does, simply this, folks. There is a button on the control S. There is a button on the control that you can push this optional stop. When the control gets down here, if that optional stop button on the control is on, okay, it'll read this, it'll stop. Now that's a nice thing because it gives you a way to search for things and stuff like that. So that'll stop things. All right, this goes up right here. G28, send everything home. We do our optional stop. We put our safety line. We activate our work offset. We do our tool change. Remember, your T number has to change the tool too. We still going to start the spindle up. All right, 1250 RPM. That's how fast we want to run on number 4 center drill. Okay, there we go. And remember, your H number has to match your T number. All right. So what else do we need here? Well, let's go back up. Always do some copying. Let me see what else I got. This is always not a bad thing to have right here. So I'm going to copy that. Like I said, I am going to resequence these. Copy. You see how that page down button works pretty good. I'm going to put this right here and paste it. That's right. Paste. Boom. Hey, what do you know? It even is the right number. M8. All right. So you might want to copy all of that. Remember, you have to change, once again, your tool number, your H number. You're going to have to calculate your RPM up, which in this case you don't have to because I just told you what it was, Control S. I spent all day yesterday on an hour video and my voice is just not recovered from it yet. So let's go N70. Again, I'm going to resequence these, so don't worry about it. Now, what's the first thing I want to do? Well, we wrap it into X0, Y0, Z.1. Let's get this back to minimized, which there. That means we wrap it right to there. So, the next thing you want to do is we're going to use what's known as a G81. All right? Now, the coolant's on. We're right here running 100 thousandths above the part on this corner. Let's say we're going to do this hole first, then this one, then this one, then this one. Okay? However you number them is your business. You could call it whatever hole number you want to call it. But I'm going to do this one first. The very first thing you do is move it into position to the first hole. So simply, we've already got G00 activated. We don't need to activate it again. I'm not going to write it down again. Remember, this is all about trying to program with the least amount of possible. So I'm just going to tell it to go to X.375 because that's where it is. It's 375 from there to the center of the hole in X. Space Y.375. If you don't believe that, right here it is. It shows you that. And also we added this up and remember, take this, take that, subtract that from it. Whatever answer you get, divide it by 2, and that'll be the distance from there to there. Because these holes are centered within this distance here. If it's centered, you can always do that. Big dimension minus little dimension divided by 2. Well, 2 inches minus 1 inch, 250, 750. 750 divided by 2 is 375. So hey, I'm in a great spot. That's all you need to put down there right there. Control S. That will get us in position. New line. Okay. Now what are we going to do? This time we're going to activate a can cycle. I'm going to introduce you to your first can cycle. Now you could do this. We could drill using G01s. But if I have one hole, I'll use a G01. It's not worth it to set up a can cycle for one freaking hole. For 4, absolutely. For 4,000, Yeah, and you're going, when will I ever drill 4,000? I had a part once, a Procter and Gamble part. It was a rotary mold. It made little bars of soap, and it had to have vacuum holes in it. It had to have 50,000 1/16 of an inch vacuum holes in it. 50,000 of them. It took me 2 weeks at 55 hours a week to drill all those holes on a CNC machine. And by God, I didn't use a can cycle. It got pretty boring. I only broke 2 drill bits. So I feel good about that. All right, enough of that. So what is it? A G81 is what we want. G81, not G84, G81. Okay, G81's can cycle. It is a standard drilling cycle. Now here's what we do. On the G81, okay, you have to give it little bit of information. Now we're already where we need to be, because before you activate any can cycle, the first thing you do is move it to the first hole. Then G81, the very next thing you're going to do, because there's not going to be any X value here, there's not going to be any Y value here, there is going to be a Z depth. So how deep are we going to do this? G81 Z minus, let's go 0.1875, that's 3/16. Okay, so that means each one of these holes, the number 4 center drill is going to go 3/16 of an inch deep. All right, usually people go anywhere from 125 to 3/16, someplace in there. Now the other thing that we need is we gonna need an R plane. Now what is an R plane? So it's an R. Now you've noticed we used R's up here. They stood for the radius. So what does R stand for when used with the G03? It stands for the size of the radius that we're making. An R and a G81 is the retract plane. So R.1. Now that means that every time this drills a hole, what it's going to do, it's going to get to there, it's going to wrap it down to 100 thousandths above the part, that's the R plane. Then it's going to feed to 187 thousandths below the part, then wrap it back up to this R plane. I'm going to say that again. The G81 will do this, okay? First, it'll wrap it to whatever position it's supposed to be in, which is already there, so it's going to stick there. You do not have to put the X and Y here. It'll be 100 thousandths above the part. That's our R plane. It's called retract plane. Some people refer to it as reference plane, but it's actually a retract plane. And then once it gets to that, it's going to feed. Now, right now, we don't have any feed. So how fast do we feed a number 4 center drill? We're going to do drill feed calculations here later on. I'm going to show you a little bit about those, introduce you to that. And I'll probably put up a video on how to do drill feed calculations too. So F, I know what I normally, dang it, I keep forgetting. Caps lock is on. I'm going to go 2.5 inches per minute. Trust me, on 90% of the jobs you do, unless you're working with some weirdo metal like Hastelloy, Alloy, Inconel, or maybe 400 series stainless, that feed will work real well for most situations. And remember, you have a feed rate override control on the CNC control anyway, so you can change the feed rate if you like anytime. I'm going to hit Control S. That perfectly right there, folks. This is all you need to activate a can cycle. Okay, let's go through it first. First, we always move to the location of the first hole we're going to drill. Then we call our G81. And you need to use that format, please. G81, then it's Z depth, then your R plane, then your feed. Now, does the control care about that? No, it does not. But remember, a lot of times we are actually writing programs that people have to read, so keep it in that format. Now, once we got the G81 activated, what do? All we have to do is put in the coordinates of our next hole. So this is the next hole I'm going to drill. Well, let me see. I got 375 plus 250. Well, I could do that, but I'll do it. Let me see. 0.375 plus 0.25. Oh, excuse me. Let's do that again. 0.375 plus 1.25. Boom. Equals 2 inches. Okay? So 375 plus 1.25. Let me try that again. That just doesn't seem right. 0.375 plus 1.25. That should not. I have no idea why it came up with 1 inch. You saw it. I did not. I'll watch it later and go, well, you hit the wrong buttons. Remember, Check your answers for reasonability. That's what I just did. So there's no way it could be 2 inches from there to there when it's 2 inches from there to there. Okay? So here's what we do. I'm only going to move what axis is that? You should have said Y. So let's get this out of here. Boom. So all I'm going to do is put Y 1.625. Control S. Make sure I hit Control S. Guess what? When it gets what it'll do it out, it's going to get to that point. It's going to drill 187,000 steep at 2.5 inches per minute. Then it's going to wrap it back up. Okay. To 100 thousandths above the part. All right. So we need another one. And remember, I'm going to resequence these. Now I'm going to do this number. All I have to do is move the x-axis to get over here. Remember, I'm setting at 100,000. I'm right here above this hole. I just drilled it. I'm 100 thousandths above the part, so I'm right up here, 100 thousandths, so I can move without hitting anything. So I'm going to go to this one. Well, let's see what that one. That's definitely going to be an x-axis move. So x what? How far is it? Well, it's 375 plus 2 inches, 250 thousandths. It's 375 from there to there. Shows you. 2 inches, 250 thousandths from there to there. So while I could probably do that in my head, 0.375, I'm watching it this time, plus 2.25 equals 2 inches, 625 thousandths. That's what I'm going to put, 2.625. Remember, you can copy and paste that too. I keep forgetting I can do that. Matter of fact, I'll do that next time. Control S. New line. Control S. All right, so what do we got? N110. All right, so I want to do this hole, don't I? Yeah. So which axis am I going to move to get there? Well, Y. Y. And this time, yep, because we know it's 375,000. See, it actually shows it over here too. I've been showing you print reading and some print reading techniques. A lot of the stuff I've done has been redundant or not necessary because there's an awful... I drew this print so that you didn't have to, it's a beginner's print. So I put more on there than normally needed. So 375, let's go ahead and take a look at that. Control S if you haven't done that lately. At that point, what we've done is, here's hole number 1. This is that. I'm not going to give them whole numbers, but this is the first hole. Okay, when it gets that, it drills it second, third, fourth. Now, don't forget, you always have to put your address. That almost looks like there's a, yeah, there's not a space there. Control S. All right, what's the very next thing we do? Now we've center drilled all 4 of our holes. Okay? You have to cancel your can cycle. For the love of God, don't forget this. And all you have to do is put a G80. That's it. Leave it stand by itself. Any good operator is going to come up here and go, oh, okay, what's going on, man? Oh, all right, there's my G80. They're looking for the G80. They really are. I'm going to put a space here to make things a little easier. That G80 cancels can cycle. So we're going to do some stuff here. Up. Always cancel your can cycle. For the love of God, if you don't put a G80 in there, I will not grade you. You'll get a 0. You're going to get a 0. Because what will happen is if you don't put this G80, the next move you make, it doesn't matter if you manually move the machine or if the machine's in a program, that G81 is still active. It's going, wherever it stops, it's going to try and drill a hole. And no, I'm not try. It will drill a hole. And if your hand happens to be there, guess what? It's going to drill a hole through your hand. If a clamp's there, it's going to drill. Bad things are going to happen. Cancel your can cycle. I'm going to put over here. Let's just highlight. We're going to copy this. You're going to see why. Go back up here. Again, we're putting notes here. Activate. Can cycle activate. Okay. All right, Control S. I got cancel can cycle. Let's get rid of that. We don't want that. There. Canned. Why can't I do this? Here we go. Alright, that works better. Can cycle activate, cancel, can cycle. We'll go back here and look at that. Control S if I haven't done it. Okay, so we activated it. Let's go over it one more time. Last time. We move it into position, the first position. We activate our can cycle. Z, that's your depth. That's how deep it's going to drill. The R plane always has to be in there. Use 0.1. I'll tell you right now, if you're doing 5,000 parts after a bit, you might change this to 10,000. So that means the part would rapid, the tool is going to go as fast as the machine can go to within 10 thousandths of the top of the part and then go into this feed right here. That'll scare the crap out of your operators. Now, over 10,000 parts, it's quite a bit of time saving. On 3 or 4 parts, it ain't nothing. So, besides that, this also, if there's something bad going to happen, it might give your operator enough time to hit the e-stop button. But seriously, on the new controls that are running at 1,000 inches per minute at rapid, there is no way you can hit the e-stop button fast enough. You're going to break a center drill, you're going to knock things out of the line, God knows what other terrible things will happen. So, don't change that R. All right. Then we just put in the coordinates of the whole, and only the x-axes that, or the axes, excuse me, that I need to move. Y, then X, then Y, then I cancel. Do not forget to cancel. All right. I'll say it one more time. Do not forget to cancel. All right. That's enough of that. All right. Guess what? We just did really cool here. We just went ahead and what did we do? All right. We just went ahead and center drilled some holes. And here's the beauty of this. I'm going to show you the beauty of it right now. Now up here, there may be some questions. You're going, was the spindle still running? Typically speaking, what happens is, if you got an optional stop, and you got the optional stop button on, the spindle will turn off anyway. And it'll wait for you to hit cycle start again. That's what it'll do. But if you're really worried about it, and it doesn't hurt, I'm going to put a space here, enter, up, I hit delete. Let's go back up here and do this again. Enter. All right. Enter again. I'll call this. It doesn't matter because I'm going to resequence, so we'll call it 04. That's fine. I'm going to put something that's maybe you haven't seen before, and that's an M05. Now, since this is the first time we've seen these M codes, the M05 and the M01, I'm going to tell you what that is right now. Spindle stop. That will stop the spindle. Most of the time you don't need it there, but an awful lot of people put it there. It makes them feel good. Go ahead and do it. All right. Now what I am going to do is I am going to do this because this is just me. All right. Not you, me. There. That's the way I like it. Control S if you haven't. So it'll do this G28. Z will go up to 4 inches above it. It'll go to machine home, which is normally a tool change position. And then in this last line, it's going to turn the spindle off. All right. Remember M09 turns the coolant off. Don't forget to do that. While the M01 would turn the coolant off. But you don't want to get sprayed with coolant if you can help it. Coolant is bad stuff. Don't let anybody tell you different. All right. So, what do we want to do? We want to do another tool change. I'm going to copy this entire thing here. Now look at here. I'm copying all of this. Let's just get this in large batch so you can see exactly what's going on. I'm copying all of this. From here, you know what? I'm even going to do something else. I'm going to copy from here. I want to get that M05 in there. All of this. Okay, now I'm going to copy. Going down here, give myself a line. Enter. And I'm going to paste. Now remember, we're going to resequence these numbers. Control S right away. I'm going to go ahead and, while I've done that. Now you're going, why did you do all that? Well, here, let me get this. Boom, there we go. Since this right here, center drilled. Okay, we got a number 4 center drill. Now, what have we got right here? Can cycle stop. Let me see if there's some other stuff we probably ought to put in there. I'm going to put another one in here too. Let's do this. I don't see my G28. There's no G28 there. Yeah, I need to put a G28 in there, so we'll go in 130 G28. Probably should have copied this too. Z4.0 M09 to turn the coolant off, Control S. So let's see what we got there. Yeah. So that basically wrap it into the position, wrap it into X0Y0Z.1, turn on the coolant. Wrap it into the position of the first hole, can activator can cycle, drilled that first hole, drilled this hole, drilled this hole, drilled this hole, canceled the can cycle. The machine went home, the spindle stopped. There. Now we're ready for our next line. So we got to do some editing. I hit Control S. All right, let's do some editing. First off, what are we going to change? Tool number. Always just change that tool number right off the bat, T03, because this is our third tool. Now, what is that going to be? Whatever the tap drill size for that is. Well, I can tell you how to do that real quick. You just take the major diameter minus the pitch. You're going, what? Yeah. So the major diameter is 250 thousandths or a quarter of an inch. Minus, okay, 1 divided by 28. You're going, what? That's pitch expressed as a decimal. Now, like I said, I try to get this thing to do parentheses. It doesn't do it well. So let's try it like this again. Let's do this first. 1 divided by 28 equals that. I will do memory store. So this means that on that particular, that doesn't seem right. I'm going to clear that again. Maybe it is right. Yeah, it is right. Because, yeah, that's right. So that means every time that you put a nut on this particular thread on a bolt, turn it one complete revolution, it's going to go about 36 thousandths of an inch. That's right. So I'm going to hit memory store. Boom. What am I doing? Again, I'm trying to figure out what size tap drill to use. So I'm going to take the major diameter minus the pitch expressed as a decimal. So that's the pitch expressed as a decimal. 1 divided by 28. There's 28 in threads per inch, so 1 divided by that tells me that expressed as a decimal. Now we'll work on this later on. This is just an introduction to it. So I got 35 thousandths right there. So let's put in 0.25. That's minus memory recall equals. Some of these are 214 thousandths drill. Now number 7 is 203. Okay, so they want a little more, a bigger hole. They want less stock in that hole. I'm not going to tell you that I know exactly what size a 214 thousandths drill is. Okay, I guess I could look it up. Let's just say right now, actually, let's look. I'm going to guess that's a number 8. I don't know what that is. Let me see what it says in the directions real quick here. Center drill, yeah, tap drill with a number 3. It's a number 3 drill. Here, see number 3, it says right here 213 thousandths. So there we go. I do know what size that was. So that's one way you can figure that out. Also, you can use tap drill charts. Type in tap drill charts. I'll actually put some tap drill diameter charts up at some place later on that you can check out, But they're everywhere. You can order pocket varieties from Starrett for free. They'll just send them to you. All right, let's clear that out of there. So, what am I doing? Well, let's go right here. This instead is not a number 4 center drill. It is a number 3 drill. I'm going to double check that one more time. Using a number 3 drill. Okay. God, cannot remember caps lock is on. Number 3 drill, Control S. Okay, so number 3 drill we know is 214 thousandths. Let's do our RPM calculations. Remember, cutting speed for this particular job is 120. So here I'm going to do it. 120 times 3.82 equals this, divided by 0.214. Now that seems incredibly fast. Well, 120 is pretty high speed. We'll double check it again, right? 120 times 3.82 equals this, divided by 0.214 equals, yep. So, you know what? 2,100. You can round these. No decimal points. Don't put a decimal point in your speed. So 2,100 and let's just go 2,100 ought to be fine. Heck, we just round it to 2,000. I think 2000 worked just great. So I'm going to go down here in the S and change that to 2000. Remember, no decimal point, Control S, no decimal point in your S word ever. Ever, ever. Don't do it. Don't do it. Don't do it. So there we go. Now, remember, your H number also has to what? It always has to match your T number. So go to your H number, make that H03, boom, Control S. Our startup block's all good to go. We got an optional stop right there. We got our safety line going. See, look, I got a G80 here. I got a G80 here. So if I have forgot to put that G80 here, this is where the safety line comes in. The G80 right here will cancel that can cycle. All right, that's a great thing. That's why we do it. Remember, always going to do it like that. Always activate. This is another reason we do it like this is let's say you ran everything or you were running the center drill up here and it broke. It broke on the second hole. Well, so you had to reset it back up and you still have to run all the holes. Well, I can come right back to this position. Okay, the center drill, I can come back to it. All right, now right now we're looking at that because I can come back to right here to my optional stop and it'll run all this and run my center drill again. Later on we'll explain how that works better. Like I said, right now we're just introducing you to these can cycles. So we've got TO3, we've got our RPM set, we've changed our H number to 803, which is important. Remember that one always has to match that one. Okay, great. Now here's the beauty of this. These coordinates, all of this is already correct except for a few things. All right, there's only a few things we have to change here. Well, these coordinates are fine. It is the depth. How deep am I going to take? Well, we know the part's 700 thousandths thick. And I want to drill all the way through it. So this has got to be at least 700 thousandths. Well, you also have to compensate for the tip of the drill. What? Yeah, there's a point on the drill. If you only go 700 thousandths, you're going to end up with the drill not breaking all the way through the part. You can guess and say, oh, 750 ought to be fine, but there's a way to calculate it up. It's just the drill diameter, and this is another thing we'll come up to more. Today's just the introduction. It is the diameter of the drill times 0.3. So we have a 214 thousandths diameter drill, right? Times 0.3. That's the length of the drill point, 64 thousandths, 65 thousandths long. So that means we have to go 65 thousandths more than this in depth or we will not break through the part. Now if it's a blind hole means it doesn't go all the way through. You don't have to worry about that. Sometimes. Like I said, there's always caveats, right? So 750,000 or 70, let me what I got, 750 thousandths would not do it. So I'm just going to add that plus 0.7 equals, wow, 764. Now let's do this, copy. Get this closer off right here. This is how deep I want to drill. Now that 0 is insignificant. Boom. Interesting that the calculator shows us insignificant zeros. That does not matter. Control S. So I'm going to go basically that 2/10 for the love of God. Get rid of it. We don't need that kind of accuracy on the depth of a drilled hole, especially one that's breaking through. All right, so 764 thousandths. Now what we did again was we wanted to go the whole thickness of the part plus the length of the drill point. And the drill point again is, I'll put that in here a second here. Can cycle activate. And I'm going to go back up to right over here. Let's go back up to where did I have the number 3 drill. And I'm going to put 0.064 drill point length control. Let's double check that. Yep, there. See, I've calculated up and put it in there. Now, that's notes for you. You wouldn't put that in the real world. Remember, we're just taking the drill diameter times 0.3. That's how you come up with it. If you're going to drill all the way through with a manual machine, you know when it's breaking through. You don't have to worry. But on a CNC, it don't know. If you just program it 700 thousandths deep, not going to break all the way through. A lot of people will even add a little extra here just in case that the angle of the drill wasn't exactly right. But I'll leave it alone. You know, you can make it 775 or something like that, but that'll be fine. Control S again. All right, now the other thing I have to do here is change the feed. Yep, that's all I have to do. So, feed. Now again, we're just showing you G81s. There will be more on how to calculate drill feeds. There'll be more on how to calculate drill point lengths, other things like that. They're very simple little calculations. Okay, I got them in my head. Like I said, drill length, drill point, the diameter of the drill times 0.3. That'll give you the length of the drill point. Okay, drill feed, that's a little more involved. All right, so let's do it. First off, let's see what I told you to use up here. I might have said tap drill with using a cans packed up. Please use an airplane drill feed can be calculated at 2 thousandths. Okay, so we're going to use 2 thousandths for every inch of drill diameter. Huh? Yeah, let me show you. Calculator time. Let's get it up here. We'll bring it over here this time. I'll go ahead and hit clear. All right. So I got a 214 thousandths diameter drill. Now, how many eighths of an inch are in 214 thousandths? Well, that's a simple division problem, isn't it? Divided by the decimal equivalency of an eighth of an inch, which is 0.125. Now, that's why you need to memorize your decimal equivalencies. Equals this. So there's 1.7 eighths of an inch in there. Once I got that number, since the formula, once again, for drill feeds is 2 thousandths feed per revolution for every eighth inch of drill diameter. So this is how many eighths inch. So all I have to do is take this times 2. So times 0.002. Okay. So every time this drill goes around, it should go down into the part 3 thousandths and 4 tenths. Now, if you put that down here, you're going to get a terrible, because remember, we don't express feeds on a CNC mill in thousandths per revolution. We express them in inches per minute. How do we do this? We just take that number times our RPM. So what is our RPM? Was 2,000. So times 2,000 equals, boom, 6.84. Let's just say 7. That'll be fine. It's aluminum. Okay. Remember, that 0 is not important, but that decimal point most certainly is. Control S. If we don't do that, bad things happen. All right? All right. At that point, you know what? Look what I just did. Okay? I went in, optional stop, always leave that on there. Safety line, activated my work offset. That way I can come to this and just run this drill if I need to. Tool 03. Set my RPM, change my H number, okay? Then I went down here and the only thing I had to change was my depth and my feed. Everything else, guess this will work. And I'm going to show you this will work. So, guess what? I center drilled it. I'm going to go ahead and cancel that out. Boom. Close it up. I have center drilled it. I have drilled it. Now let's countersink it. Let's countersink that hole. Now, if you don't know what countersink means, it just means deburring the hole. In this case, other cases we actually might do it for a flathead screw or something like that. But all right, so you know what? Here's the cool thing about this is I'm just gonna. This is all the stuff I want. I want that G28. I want the spindle stop. I want all this. So I'm going back down here, copying all this. Copy. I'm having to hit that twice. I do not understand why. Put it right there. Go paste. Boom. Remember, we're going to resequence. Control S. All right. All right. So this time I'm going to countersink. So first thing I'm going to go up here is I'm going to change that to T04. Okay. Make that H04. Just do that at the same time. Control S if you haven't done it. All right. So this is going to be what? Well, we're going to put right here. I'm going to change this little comment statement. Come on, I'm just going to maximize that for you so I can change it real easy. Comment statement. I'm going to use a 3/8 DIA. That stands for diameter. And again, Randall cannot remember that he had 3/8 diameter. 90. Yeah. Believe it or not, a part feature on a part is called a countersink. That's just what we do. And it's actually made by a tool called a countersink, Control S. So I've got a 3/8 diameter 90-degree countersink. That ought to work just fine. How fast do we run countersinks? If it's on a manual machine like a drill press or a mill, you're going to run it as slow as the machine will go. It also depends on what type of the countersink you got. There's countersinks that are solid carbide. There's countersinks that are solid high-speed steel. There's countersinks that have multi-flute. They're called chatterless countersinks. Then there's countersinks that have holes. There's just so many different types of countersinks. They all have a little bit of different speed, but the bottom line is, generally speaking, slow is the way to go. Now, I'm just going to go ahead and say in this case, I am positive that'll run at 500. I probably should check my instructions just in case, because I probably gave you an RPM in here. Let's take a look. Then tap, calculated, then tap drill diameter. I had you tap without countersinking. That was stupid of me. Let's not do that. So we'll go back to this. Okay, so I'm going to run at 500 RPM. That'll be fine. All right, so I got that. Hit Control S if you haven't done that. Remember, your H number has to match your T number. Okay, this tells us that it's a 3/8 diameter countersink. Very good. Okay, all right. So what do I have to change? Again, not a whole lot. All right, not a whole lot. That's interesting how that works. I want to get it in front of me. Okay, I like that better. You can see some of this over here. First off, well, you don't want to countersink that deep. With a 90-degree countersink, and I'm going to say this, and we will have countersink calculations put in here, the amount you go down is equal to the amount you go over per side. So I know that I need a countersink that's a little bit bigger than 1/4 of an inch. That's how deep I want that to be. So let's say 30 thousandths per side. That's 60 thousandths bigger. So 1/4 inch plus 60, I believe that's 310. 30 thousandths per side on 1/4 inch is pretty huge. Let's go 15 thousandths. So here's how we'll do that. Going here, the hole's 250. That's what size it will be. Okay, not what's that's how, because we want to make a countersink for this. So 250. All right, so I got 250, and what am I going to do with that? Yes. So I want to know how deep I'm going. Had a senior moment there. So 250 divided by 2. Always take whatever the diameter of the countersink you want it to be, divided by 2, and that's how deep you go. Divided by 2, 125 thousandths. Cool. So I'm going to go 0.125. I'm going to go that. That's what I just said. Didn't do it though. 125. Control S. All right. So now I'm going 125 thousandths deep with the 90-degree countersink. That should give me a 250 thousandths diameter countersink. Now that's not really what we'd like. We'd like it a little bit bigger. I could go, if I went 260, 200, I said 15 thousandths per side, so that's 280, 280, that's 140, right? Yep, half of 280 is 140, isn't it? Yep, it is. Control S. That'll give me a nice little countersink. Okay. Control S if you haven't done it. Feed. Well, we're definitely not going to countersink at 7 inches per minute. That's too damn fast. All right, it really is. It's too damn fast. So, generally speaking, on countersink feeds, there's a couple rules to that. Okay, there's another rule here, but I've given you a whole bunch of rules. You're going, too many rules. Don't worry. So let me see. I bet you I come over here again. Let me minimize this. Go back up here. Oh, that's right. Didn't say anything about countersinking. So stupid of me. Come back up here. So I'm going to say 2.5. I can go 2.5 inches per minute pretty easy. Now, later on we'll talk about a dwell and things like that, but we don't need to worry about that. Okay, so we're going 140,000 steep. We're still got an R plane at 100. Your R plane is always going to be 100. It's never going to change. Please do not change it to anything else. Don't send me say this is what we do at work. It's 200 thousandths or it's 50 thousandths. That's fine, but here I'm looking for 100 thousandths. Don't do it that way. I'll grade you accordingly. All right, feed 2.5. There is no real good way. Just again, countersinks like to be run slow and they like to be fed slow. All right, that's just the way that is. We don't have to change anything else. Honest to God, we don't. Control S if you haven't done that. Here, look what I did. We'll start up here. Okay, I'm going to go all the way back up here. I'm going to resequence this very shortly. All right, but from this point right here all the way down to here, I have made what? I changed 3 tool changes. Okay, so I changed from, used the number 4 center drill, then I used the number 3 drill, then I used a 3/8 diameter 90-degree countersink. And I did all that just by copy and pasting, and I only had to change a minimal amount of stuff. Don't reinvent the wheel. And what do I need right here? Well, first off, I'm going to go ahead and start, because that's stuff we'll get rid of in Predator Editor. Okay, so I got my G. What I want to do is I'm going to go in, let's just say 130. I am going to resequence G28. I'm just going to copy that because guess what? I know I got it right here. I don't need that spindle stop. Don't get that M05. I'll tell you why. Copy. Put it right here. We're always going to have a G28. All right. The last thing, well, it's going home. M30, and I said do not sequence the M30. And then one more thing, don't forget your percentage sign. Boom. Shift percentage. There we go. And Control S. Now we have a pretty viable program. All right. Great. So what I'm going to do is here, I'm going to go ahead and minimize this a second. I'm going to get rid of this. We are done with this puppy dog. Goodbye. I'll get rid of all that because you don't need that. And let's get this going here. So here's Predator Editor, which just means you can manually resequence the numbers. Some of you did not. Let's make sure you understand that. I'm looking for sequence numbers. If you're not going to sequence them, I'm going to grade it accordingly. All right. If your numbers are not properly sequenced, I'm going to grade it accordingly from now on. Hopefully you're paying attention to this. I'll make sure everybody understands that. They will. All right. So go here. Stick this in here any place, hit Control A, that selects everything. Now I am left clicking and I'm going down and I'm copying. Then I'm going over here, I'm left clicking, I put my insertion point there, left clicking, and I'm going paste. Boom, there's everything all nice and neat. I'm going to go up to process. Remember, you can download this piece of software. Resequence, I'll resequence by 10. Okay, boom, they're all done. Okay. Now I'm going to hit Control A again and copy it. I'm going to take it right back here. I'm going to go back in here, right click in here and go paste. Now my numbers are all nice and resequenced. Hit Control S. Okay, I got a good program. Now go over here and paste. There is my program. All my numbers nice and sequenced too, see? Some of you have been sending in crappy unsequenced numbers. I don't want that anymore, okay? That's why I'm showing you how to sequence. And you shouldn't. And later on, guess what? Pretty soon I'm not going to show you how to do this stuff. You're going to be doing it by yourself. Basically, once you get good with this stuff, okay, so here we go. I'm 185,000, so I'm leaving 20,000 stock on the sides. I'm milling the island. Back out to the safe point, come down. This time I should come down to 200 thousandths, and I'm not going to leave any stock. I got a different D number, so here we go. This should be finishing the island. Going off, turn it off. Okay, now we're going to go change tools. Going through here. Notice the tool does not change to drill. It doesn't know. You know, NC viewer is not that accurate. So we're getting ready to activate. Right now we're at X0, Y0, Z's 100 thousandths above the part. Okay. All right. And we're getting ready to activate. We'll go to the first hole, which is right there. Now I'm activating my G81, so Z is going to feed down, okay, to 100 thousandths above the part, which is where it's at. Then it's going to, okay, you see it's actually doing its drilling there. Goes back up. Now here comes the number, goes over, changes. We're going to do a number 3 drill. Okay. Then we'll go get our countersink. Countersinking. What I just noticed is that the NC viewer doesn't do a really good job of working with can cycles either. It looks like some of the can cycles didn't work. I guarantee this format works, but NC viewer doesn't show them that. That's too big because NC plot does a really good job of showing you. It actually drills the holes. You can see it.